Hello everyone, I am K. Harika. Firstly, I thank Emertxe for giving me this internship opportunity. I am with my fellow mates K. Lokesh, M. Pratyusha, and P. Suki have done a project on IoT based home automation under the guidance of Jayalakshmi and Daniel. Here we can see the architecture of IoT. Abstract. Home automation using Arduino PixinLab and Blynk application. Controlling garden lights based on whether it is a day or night. Controlling cooler and heater based on whether it is hot or cold, and also sending respective notification to LCD and mobile application. Controlling water level of tank based on its capacity and also sending respective notification to LCD and mobile application. Here are the four main contents of our project. Those are C programming, IoT, embedded systems, and Arduino UNO. This internship is of 4 weeks. Coming to the first week, we have learned about C programming. The topics learned in C programming are variable, operators, keywords, concept arrays, pointers, function, storage classes, preprocessor, directives, and header files. Here we can see the general aspect of C. C was originally developed in the 1970s by Dennis Ritchie at Bell Telephone Laboratories Inc. C is a high-level, general-purpose structured programming language. Instructions of C consist of terms that are very closely same to algebraic expressions consisting of certain English keywords such as if, else, for, do, and while. C contains certain additional features that allows it to be used at a lower level, acting as a bridge between machine language and high-level languages. This allows C to be used for system programming as well as for application programming. We can see the first topic, that is variables. A variable is nothing but a name given to a storage area that our programs can manipulate. Every variable in C has a specific type which determines the size and layout of the variable's memory, the range of values that can store within the memory, and the set of operations that can be applied to the variable. These are the following basic variable types. The four variable types are char, int, float, and double. The size of the char variable is 1 byte, whereas for int it is 2 byte, and for float it is 4 byte, and coming to double it is 8 type. Operators. An operator is a symbol which operates on a value or a variable. For example, we can see plus is an operator to perform addition, and minus is for subtraction, and star is used for multiplication, and slash is used for division, whereas percent is for modulo, remainder. We can see C relational operators. C relational operators check the relation between two operands. If the relation is true, it returns 1. If the relation is false, it returns 0. Relational operators are used in decision making and loops. We can see the operators, that is double equal to, greater than, equal to, not equal to, greater than or equal to, less than or equal to. We can see the examples 5 equal to 3, written 0. That means 5 is not equal to 0. So it returns 0 since the condition is false, and 5 is greater than 3 returns 1 since 5 is greater than 3. It's true. And 5 less than 3, it's not true. That means it's false. So it returns 0. And 5 not equal to 3, and the condition is true. So it's 1. And 5 greater than or equal to 3. Either of the conditions satisfies, it returns to 1. Since 5 is greater than 3, so it returns to 1. And 5 less than or equal to 3. Both the conditions does not satisfy, so it returns to 0. Our next topic is keywords. Keywords are nothing but system-defined identifiers. Keywords are reserved words of the language. They have specific meaning in the language and cannot be used by the programmer as variable or constant names. C is case sensitive. It means these must be used as it is. There are 32 keywords in C programming. There are auto, break, case, char, constant, continue, default, to, double, else, enum, extend, float, for, go to, if, int, long, register, return, short, sign, size of, static, struct, switch, type def, union, unsigned, void, volatile, while. Okay, what is an array in C? An array in C is a fixed size collection of similar data items stored in contiguous memory location. It can be used to store the collection of primitive data types such as int, char, float, etc. and also derived and user-defined data types such as pointers, stretches, etc. Syntax is intr 5. Pointer. What is a pointer in C? A pointer is derived data type in C that can store the address of other variables or a memory. We can access and manipulate the data stored in that memory location using pointers. Syntax for pointer is data type star printer underscore name. Coming to function. What is a function in C? Functions are a set of statements that take inputs, perform some operations, and produce the results. The operation of a function occurs only when it is called. Rather than writing the same code for different inputs repeatedly, we can call the function instead of writing the same code over and over again. Syntax for function is int sum of int a comma int b. Next, followed by my fellow mate M. Pratyusha.
My name is Pratisha. Before my friend explained what we learn in week 1 internship. Now I will continue with the week 2. In week 2 we learn about introduction to C++ classes, object creation, constructor and destructors, introduction to IoT and its applications, installation of Arduino IDE, null model emulator, Pixim lab and all other required laboratories, and the remainder building home automation project. In this internship, we learn a programming languages like C and C++. The difference between C and C++ are when compared to C++, C is a subset of C++. C++ is a subset of C. C++ can run most of C code, while C can't run C++ code. C supports procedural programming paradigm for a code development. C++ supports both procedural and object-oriented programming paradigms. Therefore, C++ is also called a hybrid language. In C, data are free entities that can be manipulated by outside code. This is because C does not support information ID. In C++, encapsulation hides the data to ensure the data structures and operators are used as intended. C does not allow functions to be defined inside. In C++, can be used inside a structure. C does not have a namespace feature. C++ uses a namespace which avoid name collisions. The anatomy of C is simple C++ code. File header, preprocessor directive, the start of program, comment, statement, program termination. Structure of C++ code. My first C++ code. Preprocessor directive. Include febustem. The start of program. It is a main. Comment to display hello world. Statement. Returns program termination. Return 0. What is IoT? The Internet of Things is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. These devices range from ordinary household objects to sophisticated industrial tools. With more than 7 billion connected IoT devices today, experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. By means of low-cost computing, the cloud, big data, analytics, the mobile technologies, physical things can be shared and collect data with minimal human intervention. In this hyper-connected world, digital systems can record, monitor, and adjust each interaction between connected things. The physical world meets the digital world and they cooperate. This is the architecture of IoT. In this, what is embedded system? In a combination of hardware and software which is integrated to do a specific task can be called an embedded system. It has three parts: software, firmware, and hardware. Unlike computers, embedded systems perform few specific limited tasks. Embedded devices have peripherals such as serial communication interfaces, synchronous serial communication interface, universal serial bus, multimedia cards, SD cards, compact flash. These are the applications of embedded system: camera, game machine, electronic tablet, television, industry, airline, space, broadcasting, medical, digital signaling, printer, car, mobile phone, smartphone. These are the applications of embedded systems. This is the block diagram of embedded system. CPU, software, memory, DA conversion, actuators, auxiliary systems, power cooling, diagnostic part, human input output port, AD conversion, sensors, electromechanical backup safety. Overview of the project purposes. The purpose of the document is to understand the requirements of home automation using Arduino, Pixim Lab, and Blynk application. This document will be used by the students to develop the project. The document will also be used for the required validation. Scope. The home automation should be simulated on the Pixim Lab simulator. Blynk IoT mobile applications used to control the devices. Should be able to control the lights, temperature of the home, inflow and outflow of water in the water tank. Assumptions and dependencies. Assumptions. All the peripherals are simulated and no real-time objects are interfaced. Dependencies. Based on Blynk mobile app, we are controlling devices. Blynk mobile app application, Blynk cloud server. Project requirements. The requirements of the project. Control garden lights on the basis of sunlight intensity. Lesser sunlight brighten the garden lights. If there is a sunlight is lesser, the garden lights will grow brighter. Temperature system control. Switch heater and cooler remotely. Switch heater off automatically if temperature indoors exceeds 35 degrees Celsius. Requirements. In this hardware requirements and software requirements. In hardware requirements, Arduino UNO, ETH W5500, LCD HD 44780, LDR sensor, light dependent resistor sensor, temperature sensor. In software requirements, we need Arduino IDE to code, Pixim Lab for simulation, Blynk IoT app, cloud server. These are the functional requirements. Arduino UNO is based on an 80 mega 328p microcontroller. It is easy to use compared to other boards such as the Arduino Mega board, etc. The board consists of digital and analog input or output pins, shells, and other circuits. The Arduino UNO includes 6 analog pin inputs, 6 digital pins as USB connector, a power jack, and an ICSP in circuit serial programming header. It is a programmer based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. This is the pin diagram and the pin description. In pin 0 to 13, we have digital input and output pins. This is the ARFE. This is the reset pin, USB cable. This is the power button. This is voltage regulator, crystal oscillator. This is 80 mega 328 mega microcontroller. ICSP pin, power LED indicator. These pins A0 to A5 are analog pins and these are power pins. This is reset 3.3 volt, 5 volt. This is ground pin and this is the input pin. Now next from week 3 my friend continued this.
Hello everyone, my name is Pisuki and I am thrilled to be interning at Emertxe. Just now my teammates explained concepts discussed in week 1 and week 2. Now I will continue this presentation with concepts discussed in week 3. That is hardware requirements of project that I have been working on. So let's get started. ETHW5500 is one of the hardware requirement. In this, the Arduino Ethernet Shield VI allows an Arduino board to connect to the internet. It is based on BizNet W5100 Ethernet chip datasheet. The BizNet W5100 provides a network IP stack cable of both TCP and UDP. It supports up to 4 simultaneous socket connections. Use the Ethernet library to write sketches which connect to the internet using the shield. Diagram of ETHW5500. Next one is temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and convert the input data into electronic data to record, monitor, or signal temperature change. This is the block diagram of temperature sensor. The next one is LCD HD 44780. LCD HD 44780 is dot matrix liquid crystal display controller and driver. LSA displays alphanumeric and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of a 4 or 8-bit microprocessor. The next one is LDR sensor. An LDR is a component that has a variable resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, it exhibits photoconductor. LDR is light dependent resistor. And the next one is garden light control. Description. Read the LDR sensor value based on the reading from LDR. Vary the brightness of the LED, which resembles controlling the gardening lights based on the availability of the sunlight. This is small block diagram regarding garden light control. And the next is temperature control system. Description. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35 and displayed on CLCD. Control on or off on Blynk IoT app. This is the block diagram regarding temperature control system. And user interface. Blynk application. Blynk was designed for the Internet of Things. It can control hardware remotely. It can display sensor data, it can store data, visualize it, and do many other cool things. Create widgets on mobile Blynk applications. Button widgets to control heater, cooler, inlet valve, outlet valve. Gauge widgets to display temperature and volume of the water in the tank on the mobile application. Terminal widgets to display the notifications when our threshold is crossed, like temperature is more than 35 degrees, turn off the heater. Water level is full, water inflow is disabled. Blynk IoT app. Button widgets are used to control the inlet valve, outlet valve, gauge to display volume of water in the tank, and to print the notification. Button widgets to control heater, cooler, and widget to display the temperature. These two diagrams differentiate between how we use button widgets to control. Threshold control. When the heater is on, if the temperature rises above 35 degrees Celsius, then heater should turn off automatically and message. Temperature is more than 35 degrees Celsius, turning off the heater should be displayed on the virtual terminal HT or off on CLCD. When the water in the tank is full, turn off the inlet valve automatically and display water level is full, water inflow is disabled. These are the sample project outcomes for the home automation. It is also a sample project outcome for home automation. Conclusion: using Blynk IoT application and Pixim Lab simulator, simulated home automation where LED temperature system resembles light, heater and cooler in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blynk IoT app, like button widgets, are used to control heater, cooler, LEDs. Gauge widgets to display the temperature. Now my teammate Lokesh will explain and demonstrate how our project works.
Hi all, welcome to the coding part of the project IoT based home automation. It includes Arduino, Pixim Lab, Blynk Cloud Server. So this is the Arduino ID which we are seeing now. So in this Arduino ID we are keeping separate files for each and every system, because to make our code easy, here we are defining all the required libraries for the Blynk Cloud Server, and here we are seeing the various functions which are used for Blynk Cloud. And coming to these are the various functions which are used for the turn on and off of cooler, heater and inlet valve and outlet valve based on the virtual pins that are connected, and print the notifications. Coming to these loops are used for displaying the temperature and water volume as gauge on Blynk app based on the condition, that is, if the temperature is greater than 35 degrees Celsius, then the heater gets turned off in the Blynk cloud and print the notification on the Blynk server. Coming to the serial water tank, same happens over here also. Whenever the volume of the water tank is less than 2000, the inlet valve will be turned on automatically until it gets the maximum capacity, that is 3000. Whenever the capacity gets 3000, the inlet valve will get turned off by itself. So these are the conditions we are given to the serial tank and temperature systems, and we are printing the notifications. Temperature is above 35 degrees Celsius, then turning off the heater. And coming to the serial water tank, if the volume of the water is in the tank less than 2000, then turning on the inlet valve. Whenever the volume is full, that is tank is full, then turning off the inlet valve. So these are the conditions required for the home automation for our project. And here we are initializing all the main functions, and we are calling the functions in the loop to repeat them for a certain time period. And so this is the coding for our Arduino IDE required for the IoT based home automation project. So let us see the simulation. So coming to simulation, this is a simulation part we are going to see in our project, and this is the Arduino which is used in our Pixim lab, and we are connecting some peripherals to this Arduino, that are LED, LDR sensor, temperature system and Ethernet shield for internet connection. And this serial remote tank is connected to the Arduino. Here this LED is connected to GPIO pin 3 to the Arduino, and this LDR sensor is used to control the brightness of the LED. This temperature sensor is used to control the temperature based upon the given conditions, and this CLCD which displays our temperature and volume of the water tank, and notifications of heater on and heater off, and inflow off and outflow off. So after all the connections made to the Arduino, when we are oning the heater, the temperature gets raised, and we are seeing that the temperature is displayed on the CLCD. When the temperature is beyond the 35 degrees Celsius, the heater gets turned off automatically. We can see that on our CLCD display, and the temperature gets reduced automatically. So, and we get the notifications on the Blynk Cloud server, that is, the temperature is above 35 degrees Celsius. So we are turning off the heater. This is about the heater button. Next, so coming to the cooler button, when we on the cooler button, the cooler fan gets rotated and the temperature is constant over the CLCD, that is our room temperature. So coming to tab 2, tab 2 is of serial tank, controlling of serial remote tank. When we see that the serial remote tank is already full, that is maximum capacity of 3000 liters. So when we are on the outlet valve, the water flow is getting flown outside. So when we see that when the volume of the water is less than 2000, the inlet valve gets turned on automatically. So and in that case we can turn off the outlet valve, and the volume of the water is represented on the water gauge. And whenever the volume of the water reaches to 3000, the condition gets satisfied and the inlet valve gets turned off automatically. So these are our conditions made required, and to the notifications we can see that volume of the water in the tank is less than 2000. This is the condition when we turn on the outlet valve. When we turn that outlet valve, the water gets decreased, and when it reaches to the level of 2000, we get the notification that volume of the water in the tank is less than 2000, and then turning on the inlet valve. So the inlet valve gets turned, and after getting the maximum capacity in the serial water tank, the notification we get is tank is full, and and it is also prints turning off the inlet valve. So this is the procedure required for our project IoT based home automation. Thank you.